Hi all. In number 8, we have a crop yield problem. So we know that a farmer plants apple trees in rows of 10. So we know we have 10 trees per row. In her old orchard, she planted 8 rows per acre. So we had 8 rows per acre. And her trees produced 12 bushels of apples. There's an extra line in there, 12 bushels per tree. From other farmers, she learned that planting an additional row per acre reduces the number of apples harvested by 1.5 bushels per tree. Okay, so if we add 1 row, we lose 1.5 bushels per tree. And we want to figure out how many rows would give the largest possible harvest. So we're going to assume this pattern goes both directions. If we have fewer rows, we get more bushels per tree. So basically what we're saying is the more crowded it is, the lower your yield per tree is, but there's kind of a balancing out again, right? More trees is better, but we have to balance that with fewer bushels per tree. If we do less trees, that seems worse, but if we're getting more apples per tree, it could be better. So that's what we're trying to do. So her largest possible harvest. So let's say we're interested in T equals the total harvest. And to get that, we're going to need the total number of trees times the number of bushels per tree. And I think really what we're getting to decide here, what did we say? Number of rows is how many rows. So I want my variable here to represent that. So I'm going to say, well, there's actually 2 ways to do this. I'm going to say R is the number of rows. So let me just mention that there's kind of a slick way to set this up, but it is just a trick that you have to remember in some sense. You could use the 8 rows we have as a starting place. And from there, you could just say, okay, R is the number of rows I add or remove from that. And it does make setup a little slicker, but I want to go through the other way where setup maybe is just a little bit more work, because I think it's something that just should make sense in the context of what you already know, as opposed to having to remember this trick about defining your variables. Okay, so the number of trees is going to be our 10 trees per row times the number of rows. Rows. And then again, we need to multiply that by the bushels per tree. T equals. So now we can say, okay, the number of rows is R, and the tricky part of this setup is just figuring out a formula for the number of bushels per tree. So my big thing I would point out here is that what we're told is that at 8 rows per acre, there are 12 bushels per tree. And for every row we add, that decreases by 1.5 bushels per tree. That's a linear relationship. So if we want to figure out the total number of bushels, let's say temporarily, B is the number of bushels per tree. If we want to figure out a formula for B in terms of R, we know, so we're saying B is our output, R is our input. We know that when R is 8, B is 12. And then we know that the change in B over change in R is negative 1.5 over 1. That's our slope. So we can build this linear formula. We can say, okay, our B of R formula says B of R is equal to negative 1.5 times the number of rows plus, oh, we already used b for our function. I'm just going to say question mark. Some unknown y-intercept. How many bushels would we get if there were 0 rows is the technical meaning of that, although I don't really love that because we wouldn't get any bushels. But that's still how our formula is set up. And then we just need to plug in this point. We know we get 12 bushels. So we need 1.5 times 8. Oh, I was just going to say, oh no, I'm getting 0, but I'm not getting 0. Sorry for the pause. I thought something was wrong. 1.5 times 8 is 12, which means that 24 is our y-intercept. So we know that the number of bushels per tree is going to equal 24 minus 1.5 r. Okay, so this is saying that if there were no rows, that maximum number of bushels per tree, so let's say maybe we could imagine that there's one tree, there's not even a full row, would be 24 bushels per tree. And then for every row we add, we lose 1.5 bushels per tree. And that is what goes right here, 24 minus 1.5 r. So again, hard part is set up. I'm going to go ahead and distribute through. So I have a 240r minus 15r squared. And there is at least a nice easy function to take the derivative of. The derivative is 240 minus 30r. And if I set that equal to 0, I get 240 equals 30r. Divide out. So let's see, 24 divided by 3 is 8. Okay, so my critical value is at 8 rows. How many do we have? 10. Oh, we had 8 rows. Maybe we were already at the magic spot. Okay, so we need to check and see if that's actually a maximum. This is quadratic. I probably could have done this earlier, but I wasn't thinking about it. That's a parabola that opens down. So if you just say in a few words or draw me a quick sketch, I know that that's a parabola that opens down. So I know that its one and only critical value should be a max. That's good enough for me. You don't have to do the endpoints business. Otherwise, if you wanted to do the endpoints business, I would say 0 rows is going to be our minimum. And then maybe the best way to get the maximum here would be to figure out when you get 0 bushels per tree. Otherwise, you could do a limit as r goes to infinity. So I don't even know what that is. 3/2, 2/3, 48 over 3, 16. I think at 16 rows, we get 0 bushels per tree. Oh yeah, that makes sense because we lose 1.5 per row. Anyways, you can do that, but it's enough just to say, I know it's a parabola, I know it opens down, that's a maximum. And then we just want to go back and say, what was the question? Oh, I'm moving weird things around. Number of rows that result in the largest possible harvest. So 8 rows is our answer. She was doing great already. All that work to say she already had it. Okay, so quick side note, if you're happy with that, just quit watching. But if you felt a little mystified by my setup, I will tell you about the other one. Here, let me snag a different color so you can actually see. So alternatively, you could say R is the number of rows added. Oh no, what did I do? Added to the 8. The 8 original rows is what I'm getting at there. And while you have to remember to define that way, it does make a really nice formula. So if we go back to this T formula that we had right here, and we say, okay, so T is 10 trees per row times number of rows. Okay, well, we started with 8 and we're adding our rows. So that becomes still not terribly hard. It was easy before, still pretty easy. The part that I think gets maybe the most simplified here is getting that bushels per tree. Here we could say, okay, well, at 8 trees, we had 12 bushels per tree. And we know we're going to lose 1.5 bushels for every row. And that gives us that setup without actually having to go back and do the linear calculation to get the slope. So this will give you the same answer, but be aware that what you should get, let me actually look at it, 12, 3/2. It's 24/3. Yeah. So what you should get out of this one is r equals 0 if you go through the same process. That actually does have the same meaning as our answer, r equals 8, because we defined r differently. That's telling us add 0 rows to get your maximum, and if we add 0, we have 8. So that's an alternative way to set that up. If you think you'll remember to define your variable that way, it's fantastic. I love it. If you don't think you'll remember, just make sure you think about that linear part. Okay, thanks for watching.